Today we are going to continue looking at section 3.2, polynomial functions and their graphs. So today we're going to specifically focus on just practicing more with graphing polynomial functions. So remember, when we're graphing, there's a process. There's 5 different things that we want to identify, and then that's going to help us graph. So let's graph f of x equals x cubed minus 3x squared. Remember, the very first thing we're going to want to do is we're going to figure out the end behavior. So we have to look at the degree and we have to look at the lead coefficient. So between my two exponents, 3 is bigger than 2. So 3 is an odd number, so we've got an odd degree. And the number that's in front of the x cubed is positive 1, so we have a positive lead coefficient. So anytime we have an odd degree, I know that one end of my graph is going to be rising and one end is going to be falling. Because it's a positive lead coefficient, that tells us that we're going to fall on the left and we're going to rise on the right. Because think of like a basic cubic function. A basic cubic function looks like this, okay? So we know our end behavior. Next thing we want to do is we want to figure out the x-intercepts, or our zeros. So I'm going to take my function and I'm going to set it equal to 0. So I want to factor to start solving for x. So I'm going to factor out the GCF, which is x squared. That leaves me with x minus 3. I'm going to set each of those factors then equal to 0. Because it's degree 3, that means we should have 3 x-intercepts. Well, I have to take the square root to get rid of the square. When I take a square root, it's just going to be 0. However, you're normally dealing with 2 different numbers, a positive and a negative. But because it's 0, there's no such thing as a positive 0 and a negative 0. But there are 2 of these, so this is a multiplicity of 2. And because that's an even multiplicity, that tells me that we are going to touch and turn. Then over here, I would just add the 3. So 3 is going to be a part of my answer. That's an x-intercept. There's only one of them, so this is a multiplicity of 1. Because it's an odd multiplicity, that means we are going to be crosses through it. So I'm going to plot 0, 0. I'm going to plot 3, 0. Those are 2 points on my graph. The third step is figuring out the y-intercept. So to do that, we're going to substitute 0 in for x. So we'll have 0 cubed minus 3 times 0 squared. Everything's going to turn to 0. Makes sense. 0, 0 is an x-intercept. It's also going to be a y-intercept. The fourth step is figuring out symmetry. So symmetry means substituting in negative x. So we'll have negative x quantity cubed minus 3 times negative x quantity squared. Cubing a negative is going to make it a negative. Cubing a negative, or squaring a negative, is going to make it a positive. So we'll still have the negative 3, and then now that's a positive x squared. So while the first term went from a positive 3x cubed to now a negative 3x cubed, but the second term stayed negative 3x squared, both of the terms did not stay the same. Both of them did not change. So that tells us that there is no symmetry here. The fifth step is determining the number of turning points. So at most, it's going to be my degree, which is 3, minus 1. So at most, there are 2 turning points. Because the only thing we have plotted are the x-intercepts and there was nothing else for us to plot on the graph, what I'm going to do is I want to figure out a couple more points, or at least one more point, so then I can have a better idea of what my graph looks like. We already know how it's going to be on either side. I know I'm going to fall on the left and rise on the right. I know that I want to touch and turn at the 0. So I know that since the left side's falling, I'm going to be touching and turning. So I don't know how far back down I'm going to go, but I know it's going to cross through 3, 0, and it's going to keep going up. So it might be a good idea if we just test either 1 or 2. I think I'm going to substitute in the number 2. So f of 2 means that I'm going to take 2 cubed minus 3 times 2 squared. 2 cubed is 8, minus 3 times 2 squared is 4. So really we have 8 minus 12, which is negative 4. So 2 negative 4s down here. So notice that does give us then our 2 maximum turning points. And so that would be our graph. And once again, notice it doesn't look symmetric, which makes sense because we didn't have symmetry. Let's take a look at another one. So we're going to graph f of x equals negative 2x to the fourth plus 4x cubed. So going through our process, we need the end behavior. So between the exponents of a 4 and a 3, 4 is the biggest, and 4 is an even number. So we have an even degree. And if you look at the number that's in front of that, it's a negative 2. So we have a negative lead coefficient. So anytime we have an even degree, that tells us that we're going to be either both sides rising or both sides falling. When we're talking about a negative lead coefficient, we are going to fall on the left and the right. So both ends should be pointing down. The second thing we want to do is figure out our zeros or our x-intercept. So I'm going to take my function and I'm going to set it equal to 0. So the first thing I'm going to do is I'm going to factor. I'm going to take out a negative 2 as well as an x cubed. That leaves me then with an x minus 2. I can set each of those factors equal to 0. So I divide by negative 2. That gets me x cubed to be 0. I'm going to take the cubed root, but the cubed root of 0 is still going to be 0. But because it was a cubed root, there are technically 3 of them. So this is a multiplicity of 3. So an odd multiplicity tells me that we are going to be crossing. So crosses through. So I can plot 0, 0. I know that my graph's going to have it going through that point. The other 0 would be me adding 2. So 2 is another 0. There's only one of them, so this is a multiplicity of 1. It's another odd multiplicity, so once again, it's another crossing. So we're going to have 1. No, wait, sorry, no, 2. So 2, 0, I'm plotting my point. I know it's going to cross through. We also need to figure out the y-intercept, so I'm going to substitute in 0. So when I substitute in 0, we'll have negative 2 times 0 to the fourth plus 4 times 0 cubed. Everything's going to turn to 0. Makes sense. 0, 0 is an x-intercept. It's also a y-intercept. Fourth step is figuring out symmetry. So I want to substitute in negative x. So we'll have negative 2 times negative x to the fourth power plus 4 times negative x cubed. Well, a negative raised to an even exponent is going to turn it positive, but the negative 2 is still there, so it's negative 2x to the fourth. When we take a negative number and we raise it to an odd an odd exponent, it's going to then turn negative. So 4 times negative 1 is negative 4x cubed. Now, because the first number of negative 2 didn't change, but the second number of 4 did, because they both aren't the same or they both didn't change signs, there is no symmetry here. We want to figure out the maximum amount of turning points. So that's our degree of 4 minus 1. So there's at most 3 turning points. All right, so I do want to test out a couple more points just so I know what the heck is going on. Okay, anytime we have a degree 4, it should look something like a W. Okay, so we know when it's x squared, it's going to look like a U. When it's an x to the fourth, it's going to look like a W. So that's what I'm kind of looking for here. I know that it's going to fall on both the left and the right, and I know it's going to cross through 0 as well as 2. Okay, I think I'm going to test, I'm definitely going to test the number 1. So when I test 1, I'm going to have negative 2 times 1 to the fourth plus 4 times 1 cubed. So that gives me then -2 plus 4, which is 2. So I know I'm going to have the ordered pair 1, 2. And then right now, like I said, I know that it's going to be going down on either side. I know it's going to cross through, and it's going to cross through, and it's going to head down. But I got to figure out, it's got to look like a W. And right now, if I just connect the points, it's going to look like a U. So I think I'm going to do one more point. I'm going to do like a half. So let's figure out if I do -2 times a half to the 4th power plus 4 times a half cubed. So if I plug that into the calculator, looks like it's going to give me 0.375. So it's going to be something like So definitely got that little tiny W thing happening, but it's definitely not symmetric here. But something like that would be my graph. And remember, these graphs don't have to be absolutely perfect, but we obviously need the end behaviors correct. We need the X and Y intercepts correct. And it's always a good idea to test just a couple of points. I'm not asking for like 10 points here. So just a couple of points. Sometimes one is sufficient enough, but I knew that it needed to be a W, and just testing 1 point wasn't going to show me how it was a W. So that's why I tested 2. All right, so remember when I give you a picture and I'm asking you to find the zeros, we're looking for the x-intercepts. And so then after I find those x-intercepts, I'm going to state whether or not the multiplicity is even or odd. So in this picture, it looks like there are 2 spots that touch the x-axis. So those are going to be my zeros. So if I look, remember the first set of brackets here are representing how the x's are going to go, and that last number is telling me the scale of the tick marks. So it looks like everything's going up and down by 1. So if I go from the origin and I go to the left, I have 1, 2, 3. So it looks like -3, 0 is one of my x-intercepts. And then on the right side of the origin, it's 2, so 2, 0. So those are my zeros. And then if I want to state the multiplicities as even or odd, well, I see that both of these are touching and turning. They're not crossing through and going to above the x-axis. So when they're touching and turning, both of these look like they are then going to be an even multiplicity. Okay, because remember, even multiplicities touch and turn. All right, so the next thing we want to do is write an equation expressed as a product of factors. We want a lead coefficient of either 1 or -1, and we want to make the degree the smallest as possible. Notice in this picture, both sides are heading down. So when they're going in the same direction, it's going to be an even degree. So I know that we're talking like a square or to the 4th power, to the 6th power. And because they're both heading down, hopefully we're okay with noticing that my lead coefficient has to be negative. So if I'm writing my function, I know that I'm going to start with a -1. Identifying those zeros is what helps me out here. So because I know -3 is a 0, I need x plus 3 in the parenthesis. Because it touches and turns, I know I have an even multiplicity, so that means that my exponent has to be an even number. And since they want the smallest degree, the smallest even number is 2. And then same idea, my other 0 is 2, so that means I want x minus 2, but because it was touching and turning, it's an even multiplicity, so I know that that one's going to be squared as well. So there's my function. And then the last thing it's asking for is a y-intercept. So I need to look at the y-axis. So notice that that's this point over here. And I look at the second set of brackets. The last number is 4. So that tells me my tick marks are going up and down by 4. So I'm going to start counting. We got 4, and it's -4, so -8, -12. So let's see, 1, 2, 3, 4, 5, 6, 7, 8. Looks like it's hitting the 9th tick mark. but they're going by 4s. So 9 times 4 is 36. It's negative. So it looks like we've got a y-intercept at 0, negative 36. So I would suggest that you pause the video, try this checkpoint problem, graph f of x equals negative x times x plus 1 times x minus 2. So here are all my steps. I have an odd degree, negatively coefficient, so it's going to rise on the left and fall on the right. It was already factored. I just set each factor equal to 0. Everything is a multiplicity of 1, so all of those zeros cross. We're dealing with a y-intercept at 0, 0. There's no symmetry in this because not every sign changed. So while all of the x signs changed, the positive 1 inside parentheses still stayed positive 1. The negative 2 in parentheses still stayed negative 2. So not all the signs changed, so no symmetry. There's at most 2 turning points, and I threw in a couple of extra points to kind of see what was going on. So there's my graph. So that's us graphing polynomial functions.